For this problem, we have a mass that we're trying to push up an incline of 15 degrees, and we're trying to figure out the friction to see how much it's going to take to be able to push the mass uphill. You have the coefficient of static friction, which is 0.42, and the coefficient of kinetic friction, which is 0.33, and a mass of 510 kilograms. There's your force body diagram. You have your forces of static, which is mu of s. And you have your force, your normal force coming from up here, and your mass of gravity coming down in the theta, which is 15 degrees. Your sigma F net is equal to 0 because there's no acceleration. All forces acting on the x, sigma F of x equals, it's negative because it's going to the left, the static friction, plus the friction that's keeping it from the block from going up, minus mass of gravity, which is coming down. And all of these are acting on the x-axis. Normal force is going up with respect to the y-axis, so you wouldn't put it in here. The static friction can be known as mu of s times n, and you can substitute that out, and then you want to solve for the friction because that's the number that you don't have. So you'd subtract mu of s times n to the other side, and your negative mg sine of theta to the other side as well. Those both end up giving you positive with the friction alone. This is sine theta because for that angle right there, you're doing the x, so you have to do the opposite over the hypotenuse. And then all forces acting on the y-axis is n, which is your normal force, minus mass gravity. Cosine of theta is cosine because you're using the y. And you want to get the normal force by itself because that's the one you don't have. So you add this part to the other side, and then you put them both together, and you have n equals mass gravity cosine of theta, so you can plug that in up here. So you plug that in right there, and then when you go to start solving this mass gravity, you can isolate that out of there, or factor it, and then you plug in everything that you know. 510 kilograms, 9.8 newtons per kilogram, and then 0.42 cosine 15. It's the coefficient of static friction, and plus your sine 15 degrees. And you work it out. 510 times 9.8 is 499.8 times 0.406 plus 0.259. And you multiply that out, and it gives you the force takes 3,323 newtons.